Hello people, welcome to EduRev. So today we'll be practicing questions on the chapter Units and Dimensions. Every year, at least one question in exam is based on this chapter. The concepts of this chapter are used throughout physics. We can sometimes also use the concept of this chapter to eliminate some options in MCQs. I have divided this chapter into three parts. The first part contains on deriving a formula. The second one has questions based on the topic, that is significant digits, or you can say significant figures. And the third part has questions based on calculating errors. So without further ado, let's crack JEE. Let's start with type 1 questions, that is deriving the formula questions. So the first question states what? The first question states that a force of viscosity F, that is acting on a spherical body moving through a fluid, depends upon what? Velocity, radius and coefficient of viscosity, that is neta of the fluid. Now we need to use dimensions to obtain the formula of F. Now in the question it's given that F is directly proportional to V. Alright, now I do not know what power of V it's directly proportional to. So I'll assume it's A. Similarly, it's given that it is directly proportional to R, that is radius. So I'll take the power of radius as B. And it's also given that F is directly proportional to the coefficient of viscosity, that is neta. And the power is going to be what? C. So now, according to these three, what we can do is, I'm going to write that F equals to K, V to the power A, then this, and then finally this. So now K is going to be what? K is the dimensional constant. So just keep in mind that it is nothing but dimensional constant. Alright. So now what I'm going to do is, I'm going to write the dimensional formulas for all the four figures that we have. That is, we have force, we have a velocity, we have radius, and we have coefficient of viscosity. So I'm going to write the dimensional formulas of all these first of all. Now for force, we know the dimensional formula is what? It's M, L, and T. For velocity, we have what? L and T. Then for radius, we have L. And for coefficient of viscosity, we have M, L, and T. Now, when I'm going to substitute for the dimensional formulas in equation 1, which equation? This equation. Then what is going to happen? So let's substitute all these formulas into the equation 1. So what basically we need to do? We need to substitute all of this into this equation that I am highlighting right now. Alright, so let's do it. Okay, so I will basically write that F equals to K C. So here I am going to write M equals to K. Then basically here you need to point out one thing, that K is what? K is the dimensional constant. So K is not going to have any dimensions. So I should not mention K here. So if I'm going to erase it, so K shouldn't be here. Yes. Then V is what? L. A. Then R is what? L. And finally, coefficient of viscosity is M. This is C. Now when I'm going to open it, it will be simply M, L, T equals to M. L will be A plus B plus C, and T will be minus A minus C. Now the next step is that I need to compare. Now you can see that M is here also and here also, whereas L is here also and here also, and T is also on both the sides. But the power of all these three are different on both the sides, and this is just not possible, right? So what we need to do, we need to equate the powers, and when I'm going to equate the powers, then I will get three equations. Now I have three numbers, that is ABC, and three equations. we can simply solve these three equations and find these three. And then we can substitute these three into this formula, that is the main formula which we wrote in the beginning, and we'll finally get the formula, that is the expression for f. Simple. So when I'm going to arrange, now in accordance to principle of homogeneity, the dimensions of the two sides of relation 2 should be the same as I've told you. So let's compare. So C should be equal to 1, then A plus B plus C should be equal to 1, and minus A minus C should be equal to negative of 2. Now because C is 1, so A should be what? Minus A, these are the three equations. A should be what? Minus A minus 1 equals to minus 2. That is minus A equals to minus 2 plus 1. That is A should be equal to what? 1. So because A is 1 and C is what? 1. So what should be B? Now if I'm going to put this into the equation, sorry, here negative is going to come. So A is 1, A plus B minus C equals to 1. So if A is 1, we need to find B, and C is what? C is also 1 equals to 1. So B is also what? B is also 1. So that means A equals to B equals to C equals to 1. And because of this, I'm going to write my formula as what? Just a minute. Yes, if I'm going to erase all of this. Yes. So I know that A is equal to B equal to C equal to 1. So I'm going to substitute this into this. And when I'll do so, F will be equal to K, V to the power 1, R to the power 1, and neta to the power 1. Simple. So this is the result, and this is the formula of F, and we have obtained this by method of dimensions. I hope you understood this. Now let's move on to another question. Alright. So let's see what the second question says. Now second question is exactly same as the first question which we just solved. It's just given in a bit elaborated format so as to confuse you people. But do not worry, let's solve it together. So this question states that the speed of sound V in a gas might possibly depend upon pressure, the density, that is rho, and the volume, that is V of the gas. We need to use the dimensional analysis to determine the exponents of x, y, and z in the formula that is given. Now in this question, the formula is already given to you, right? In the previous question, we derived the formula, but in this question, the formula is already given. We just need to find out the exponential values of, P, rho, and the volume. Now, C is what? C is your dimensionless constant, so we do not have to worry about C. Now, incidentally, the MKS units of the pressure are kilograms per meter per second per square. So yes, let's start. So basically what they are saying is that V equals to C, P to the power X and rho to the power Y, D to the power Z. Now let me straight away write the dimensional formulas of these. So the dimensional formula of V is nothing but L by T. Now the dimensional formula of C is going to be nothing because it's what? It's dimensionless constant, so no dimensions. Of P is going to be M T square L to the power X. Then for rho it is M L cube Y, and for volume it is L cube Z. Now when I'm going to solve it further, it will be what? L to the power 1 T to the power minus 1 equals to M X T2x minus T2x. L is minus x. Similarly, M is minus y plus y. M is minus 3y. L is 3z. So when I'm going to solve it further, it will be L1 T minus 1. Now M is going to be x of this plus y of this. T is going to be minus 2x of this, and then L is going to be minus x minus 3y plus 3z. Now when I'm going to compare the left hand side and the right hand side, you can easily see that on the right hand side I have M, T and L, whereas on the left hand side I only have L and T. So to just balance the equation a bit, what I can do is I can put M to the power 0 on left hand side to balance both the sides, that is left hand side and right hand side. Now what I need to do is I need to balance the exponents of the two sides. So what I'm going to write is I'm going to write x plus y will be equal to 0, minus 2x will be equals to minus 1, and minus x minus 3y plus 3z will be equal to what? 1. Now when I'm going to solve this equation, that is minus 2x equals to minus 1, I'll get that x is nothing but x is half, correct? Now if x is half, and whenever I am adding x and y, I'm getting 0. So that means y is nothing but y is negative half, correct? So if x is half, y is nothing but y is negative of half. Now I have one more equation, that is minus x minus 3y plus 3z equals to 1. So now when I am going to substitute the values of x and y into this, I will get a value of z which will be equal to 0. That is, if I am going to substitute the values, it will be minus of half minus plus of 3 by 2 plus 3z equals to 1. So 1 and a half is going to be 3 by 2. 3 by 2, this and this will get cancelled out. So z will be equal to what? 0. Therefore, I would say that value of x is half, value of y is negative of half, and value of z is 0. Now I need to substitute these three into the formula that was given to us. So when I'm going to substitute into the formula, it will be what? It will be that v equals to c, p to the power x is half, rho to the power y is negative half, and v to the power z, that is 0. So v will be equal to c under root of p by rho. And this is the formula which we will get at the end. I hope you people understood this formula. Now we are going to move on to type 2 questions. Now the second part of the questions on significant digits. In this case, I'll help you to revise the concepts of significant digits as well. The second part of questions are on significant digits. Do not worry if you do not know these. I'll help you to revise the concepts of significant digits. Now to determine the number of significant digits in a number, we use the following 3 rules that are presented on your screen. The first is that non-zero digits are always significant. The second says that any zeros between two significant digits are significant. Like for example, if I have 1001, so these two zeros that are between these two non-zero numbers, they are significant. Then they are saying that non-zero digits are always significant. Like for example 2, it's always significant. Now the third one says that a final zero or trailing zeros in the decimal portion is only significant when, like for example, if I have 0.500, okay, or maybe 0.63200 and 0. Now these zeros are significant, okay. These zeros that are after the numbers, these are significant. But on the same page, if I am going to tell you that 0.006 is a number and 0.000968 is a number, then the number of zeros that are preceding these non-zero digits, they are not significant. I hope you understood these three. Now quickly recap how you can do addition, subtraction, multiplication and division with significant digits. So for your subtraction and your addition, first of all, you need to count the number of significant digits in the decimal portion only of each number in the problem. Then you have to add or subtract in the normal fashion as you do it. And lastly, your final answer may have no more significant digits to the right of the decimal than the least number of significant digits in any number in the problem. So you need to keep this in mind, that it should be not more than the least number of significant digits that are in any number in your problem. Similarly, if you do it for multiplication and subtraction, it will be that the least number of significant figures in any number of the problem determines the number of significant figures in the answer. You are now looking at the entire number, not just the decimal portion. This means that you have to be able to recognize the significant figures in order to use this rule. That is, for example, 5.26 has how many significant digits? 3 digits. Whereas 6.1 has how many significant figures? It has 2 significant figures. I hope you people understood this. So let's move on to the question. That is question number 3. Alright, so let's see what the question number 3 says. So question number 3 says that the number 2.745 and 2.735 on rounding off to 3 significant figures will be what? Now the key concept here is that while rounding off measurements, we use some of the rules, and that is like by convention. And what are these rules? Let's find out. So if the digits to be dropped is less than 5, then the preceding digit is left unchanged. Alright. Whereas if the digit to be dropped is more than 5, then the preceding digit is raised by 1. That is, that if the number that I am dropping, if that number is less than 5, then the number that is preceding that number will be unchanged. Whereas if that number is greater than 5, then it will be what? It will be changed. That is, it will be increased by 1. Like for example, if see this number, okay, 2.73. Now if I'm dropping 3 is what? Less than 5. So 7 is going to remain unchanged. Whereas if this number would be 2.78. Now 8 is greater than 5. I'm dropping it. So this number will precede by 1. That is, it will be 2.8 now. Correct. But the thing is that we only discussed what will happen when the numbers are greater than 5 or the numbers are less than 5. We never talked about what if that number actually is 5. So what's going to happen at that point? Now if the digit to be dropped is 5 and it is preceded by, let's say, 0, then the preceding digit will be raised by 1. That is, for example, if it is 2.05 and I have to drop 5, then the preceding digit will be what? 2.1. And if the digit to be dropped is 5 or 5 followed by zeros, then the preceding digit is left unchanged if it's even. That is 2.45. Now if I'm dropping 5, this is even, so it will be left what? Unchanged. But if it's odd, then it will be raised by 1. That is 2.75. So it will be raised by 1. Perfect. Now let's see what this question says. So we have two numbers and we have to round them off to 3 significant figures. So let's round 2.745 first. Now here the digits to be dropped is what? 5. So I have to drop the digit 5 here. Correct. Now the preceding digit to the left is left unchanged because it is what? Even. So it will be what? It will be 2.74. Correct. Next is 2.735. Now when I am dropping 5, the digit that is preceding 5 is odd. So I have to do an increment of 1 interval. So it will be what? 2.74 again. So it has to be 2.74 and 2.74. That is option number D. Perfect. I hope you understood this. Now let's move on to the next type of questions, that is type 3 of questions. Alright, so let's start with question number 4. Now keep in mind that this question came in JEE 2004. So if you are able to solve this question, that means you have a good hold over this chapter. So let's read question. So a wire has a mass of this and radius this and length this. So the maximum percent error in the measurement of its density is going to be what? Now the thing is that the density of the wire of mass m, length L, radius R will always be given by what? Rho equals to m by volume. And this can be further written as m upon pi r square L because radius and length of that particular wire is given to us. Now, the thing is that we have to differentiate this equation and divide it by what? Rho. Because when we are going to divide it by rho, we'll get the terms as delta rho, delta m, delta R and delta L. And then we can further solve it and find out the actual maximum percent error in it. So when I'm going to differentiate this equation with rho, it will be what? Rho, delta rho by rho max will be equal to delta M by M plus 2. Why? Because we have R square. Delta R by R plus delta L by L. So this is what is going to happen when I am going to differentiate the above equation. Now from the data that is given, I know that M is 0.3 grams and delta M is 0.003 grams, whereas radius is 0.5 mm and delta R is 0.005 mm. L is 6 centimeter and delta L is 0.06 centimeter. So I'm going to substitute these values of M, and this is basically delta M, then R, and this is basically delta R, then L, and this is basically what? Delta L into this equation, and then we'll solve again. So delta rho by rho is going to be what? So delta M is what? 0.003 upon M is what? 0.3 plus 2 into delta R is 0.005 upon R is 0.5 and delta L is 0.06 upon L is what? 6. So this whole, when I solve it, it will be what? 0.04. Now I need to find the percent, so I have to multiply it by 100, and multiplying it by 100 will give me what? 4%. So the maximum percent error in the measurement of density is going to be what? 4%. That is option number D. I hope you have understood this. Now let's move on to the last question for the day. That is question number 5. So basically this question is saying that we have to measure two quantities A and B, and we should report the correct value of under root of AB. Now the thing is that this last portions are the amount of error that can happen when the two quantities were measured. That is, when A was measured, then plus minus 0.2 is the error that can occur in the measurement of A. Similarly, when quantity B was measured, then plus minus 0.2 can be the amount of error that has occurred when we were measuring B. Now we need to find out under root of AB. So that means that when I am finding under root of AB, then the final value which I get, that will also have some form of error. So to find out that error, what I am going to do, initially I am going to find under root of AB as a whole, and then we will differentiate the equation to find out the error as well. So how we are going to do is, let's suppose that Z is nothing but under root of AB, and A is nothing but it is 1, and B is nothing but 2. So Z is nothing but under root of 2, and under root of 2 is nothing but 1.414 meters. Correct. Now rounding off to two significant digits, I can say that Z is nothing but 1.4 meters. Correct. So when I am going to differentiate this equation, it will be delta Z over Z equals to half delta A by A plus half delta B by B. Now I am going to substitute the values that is given in the question into this equation. So delta Z over Z is going to be nothing but half. Delta A is what? Delta A is 0.2 and A is what? A is 1. Similarly, delta B is what? Delta B is 0.2 and B is what? B is 2. And when I am going to solve this, it will be what? It will be 0.15. So I know what is delta Z. Delta Z is 0.15. And I know what is Z. Z is 1.4. That means the final value, that is Z plus delta Z, or I can say under root of AB as a whole, is going to be what? It will be 1.4 plus minus 0.2. Why 0.2? Because I have rounded this off. So when I am going to round this off, I have to drop down 5. When I am dropping 5, 1 is going to convert to what? 2. So it will be 0.2. Therefore, I have written Z as what? Z that we calculated, and it came out to be 1.4 plus minus delta Z, which is nothing but 0.2. So the answer has to be 1.4 plus minus 0.2. That is option number D. I hope you people understood all these questions and now you know how to solve the questions of units and dimensions. You can go to EduRev and attempt all the tests that are given there. You can also unlock all the logged contents, that is documents, videos and tests through EduRev Infinity and Acer exams at less than 80 rupees per month. Thank you.